Hello and welcome to another video. In this video we're going to be working on Hand of Straights. And in this one you have some number of cards and you want to rearrange the cards into groups such that each group is of group size and consists of consecutive cards. So given an integer array hand, you want to see if this is possible. So in this example here, you have a hand and you have a group size, and so you can rearrange it like this. This is like one way to do it. So essentially, and every group has to have consecutive numbers. So like if it starts with 1, it has to go 2, 3, and so on and so on. So in the second one, you can't do it. So you just don't return anything, or you return false because obviously. So one thing you can do really quickly is for a group size, like if a group size is 4 and an array has 5 elements, you obviously can't divide it into groups of 4. So if the length of your array, mod group size, is not 0, then you can just return false. Right, so that's pretty straightforward. So if you have an array of 15 elements, you can't split it into groups of 4. Now the tricky thing is, how do you pick these numbers? So we have these numbers sorted. So what you can kind of do is like a greedy, quote unquote. So let's say you have this. You know that like, okay, I have this element. So this element has to be the start of a group, right? So my smallest element in my array has to be the start of a group because there's nothing before that. So if it is possible, then my smallest element has to be the start of a group. So let's say I take this element, and let's say the group size is 3 here. This is this first example. So I can just take this first element, and I can put it in a group. Okay, well, what has to be after it? It has to be the first element, so then you have to have a group of 2 and 3. So if this is not possible, then you can't do this. So I use 1, I use a 2, and I use a 3. Okay, well now, this is my smallest element. So because this is my smallest element, this has to be the start of a group again, right? Because there's nothing that can be smaller than it. So you're basically kind of forcing like the start of a group. So if you have a bunch of elements, the smallest element has to be the start of a group. It can't be in the middle. It's not possible. So by saying 1 had to be the start of a group, we knew our group had to be this. Now our second group has to be 2, 3, 4. Like this. And now our third group has to be 6, 7, 8 because 6 is our smallest element. So if we know where our smallest element is, we can make a group. But the problem is now, how do we do this efficiently, right? Because like, well, what if our group's really big? Like, how do we know, like, let's say we know for sure what our starting smallest element is, but then how do we know what the next one is? And it turns out you actually don't need to know what the next one is. You can kind of just go through your array in order. So what you can do is you can have a sorted array, and then you know for sure like what element you're on. So we're going to start this one. And you can also have a hash map of counts. So we have 1 equals 1, 2 equals 2, 3 equals 2, 4 equals 1, 6, 7, and 8. And so we have our hash map of counts. And now what we can do is we can just say, okay, well, we know this has to be the start. So our first array has to be 1, 2, 3. So let's just make sure we have 1, 2, 3 in here, and let's decrement all their counts. So let's do that. So this becomes 0, this becomes 1, and if one of those numbers isn't in here, then we know for sure that this is not possible. So we know that our array has to start with 1, so we can just look for 1, 2, 3 because that's our group, and then do that. So that's one group. Okay. Now we check again. Because like your array might be like 51s. Now we check again for this number. Does this number exist in our counts? Do we have a count of greater than 0? No, we don't. So we can move on to the next number. So now for this number, do we have a count of greater than 0? And you can see how like this way we're always picking the min element in the group because we're just checking as we go down this array, do we have this number in our counts? If we don't, we can skip it and go to the next one. So here, is this number in our counts? Yes, it is. So then we know for sure our group has to be 2, 3, 4. And if 2, 3, 4 doesn't exist in our counts, then we return false again, but 2, 3, 4 does. So we decrease all those. Now we check again. Is the count of 2 greater than 0? No, it's not. So we go to next number. Is the count of 2 greater than 0? No, it's not. So we go to next number. Is 3 greater than 0? No, it's not. So next number. Is this? No. No. And now this is the next number with a non-zero count. So we know for sure that has to be the start of a group. What group does it have to be? Well, it has to be 6, 7, 8. So we check for 6, 7, 8, and we decrease all of them. Then we no longer have 6s, so we move on to the next one. Do we have any of these? No. Do we have any of these? No. And then when we're done, we just return true. So by having both of these data structures, a sorted array and a hash map, you're able to know for sure what's the start of a group. And then for that given start of a group, you know exactly what has to be in the group because you know the group size and every element has to be one bigger. So you just check in the count, is that possible? And if at any point it isn't, you just return false. So that's what we're going to code. So we're going to create a sorted array and then a hash map, and then we're going to go through this array. For every single number, check, is it in our hash map? If it is, we'll make the group. And if we can't make the group, we'll return false. And if we're able to get through this whole array, then we just return true. So let's do that. So first thing, we can sort our hand. So you can also like take the keys of the hash map and sort it if you want, because like imagine you have like 5,000 ones. You could do that too. So, but you know, worst case, it's going to be the same time complexity. So it doesn't really matter. Okay, so now we need to make a hash map. So we'll say integer counts, and then we need to go through our hand and put the numbers in there. So for int num in hand counts, put num counts getter default num, and the default value will be 0 plus 1. So now that we have our hash map, now what we need to do is we need to, let's tab this correctly. Now we need to go through our hand, and then for every single element, we need to check, is it in our hash map? If it's non-zero, then we need to try to make the group. So we can say for int num in hand, while counts get num does not equal 0, while this number exists, then we can try to make the group. And so for the group, we'll say, so basically, how long is the group? So the group is going to be length group size. So we can say for int I equals 0, I is less than group size, plus. So what's our current number going to be here? It's going to be num, which is our starting number, plus I, right? So if we start at 1, it'll be like 1 plus 0, 1 plus 1, 1 plus 2, and so on. So we have to check, is this current number in our counts? And is that count greater than 1? Or is that count greater than 0? So we can say if counts getter default num plus I, or actually we can store the number, so we can say like int cur or something, counts getter default num plus I, and then we can have a default value of 0. And if this current count is 0, then we don't have this number to put into our group, so we can just return false. So we can say if cur equals 0, just return false right away because we can't put in the group. Otherwise, we are going to take our number and decrease its count. So we can say counts put num plus I is going to be the number, and then the count will be cur minus 1. Okay. And if we're able to make the whole group, then we're done with an iteration of the loop. Then we just come back to the number and check, do we have that number again? And then we keep doing that. And then if we're able to get through every number and we no longer have them in our hash map, then we basically succeeded. So we can just return true here. All right. And there we go. So pretty efficient. So yeah, the main tricky part is like you should be able to realize I want to start groups from the first number, because then you know exactly what your group has to be, because if you have to include the first number and there's nothing smaller, then you know your group has to be like first, second, third, all the way up to group size. And then if you do make one group, how do you know the start of the next group? You can just sort your array, and then for each number, just check, is it still in our hash map? If it's not, move on to the next one. So time complexity and all that. So let's think about it, I guess. So what are we doing? So we're sorting our arrays. That's unlog n already. Like I said, you can probably make it a little bit more efficient if instead of sorting your hand, you first get the key set of the hand. So you can take like, because you don't need like if your array is like, imagine it's like 1, 1, 1, 1, 1, 1, 1, 1, you know, whatever, 2, 3. You only need each number one time. So you can just take a set of it if you want to and sort that. That's fine too. Okay. Yeah. So then we make our counts, and to make our counts, that's so then we're looping through every number and we're looking in the counts. So I think that's going to be like, I want to say O of n, or maybe like n. So every so the total counts of every single number is n, right? Like in here, all of these add up to n. So when we're actually looking for these, anytime we ever miss, we return false right away. So it's not like we're going to be going through all these unnecessary groups. Anytime we try to make a group with a number that doesn't exist, we just return false right away. So the only thing we could do is like maybe sometimes for a number it won't be in our counts, but if it is, we're going to go through the group and make it. So I think this is going to be basically like, it's going to be like O of n plus n, which is just O of n. Yeah. So that's going to be n log n space. So obviously, if every number is unique, then the count is going to be O of n. So that's going to be worst case. And yeah, we don't use anything else, so it's going to be like this. So hopefully this was helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.